We're going to start our lesson for Tuesday, April 21st. This is lesson 3 in the topic. And we're going to start with our warm-up here. So our warm-up is just solving equations, right? We're going to solve and isolate the variable. So we're going to use those properties of equality to solve for this variable. So in order to isolate h, I need to subtract 120 from both sides. So h equals 315 minus 120, because if I subtract 120 from positive 120, it gets just h, and then that would equal 195. And I was able to do that in my head because I know that 15 is 5 less than 20. So if I take that away, it's 95 plus the other 100 is 195. All right. Now I have w minus 17 equals 38. So I'm going to need to add 17 to both sides. When I do that, w equals 38 plus 17, which is going to equal 55, because 8 plus 7 is 15, 30 plus 10 is 40, 15 plus 40 is 55. That's how I do that in my head. All right, now I've got something with a multiplicative relationship. So I have c equals c over divided by 5 equals 12. So in order to do this, I need to multiply both sides by 5 in order to get 5c over 5. That equals just 1c, or c. 12 times 5 equals 60. And I know that in my head because 5 times 10 is 50. 5 times 2 is 10. 10 plus 50 is 60. And then finally, I have 169 divided by, or equals 13 w. So I'm going to go ahead and I'm going to divide both sides by 13. Okay. And I'm going to get, that's going to equal 1. So w is going to equal, and we're just going to go ahead and I'm going to use this as an opportunity to share an example of long division again, because we haven't had one of those in a while. So I can set it up like this. How many 13s are there in 1? 0. How many 13s are there in 16? 1. So I take 1 times 13, subtract it from the 16, I get 3. I can drop my 9 down. I have 39. I know there's 3 13s and 39. And I have no remainder. So 169 divided by 13 equals 13. So w equals 13. That's one that I knew just from knowing squares, but it's still a good example to just take a look at some long division there as well. So once the warm-up's done, you can write down your essential question. How do we use 4-quadrant graphs and equations to solve real-world problems? I did that 4-quadrant graphs in there because we're going to use those. We're going to find examples of data where we would use just a 1-quadrant graph and some where we would use a 2-quadrant graph. So let's take a look at our getting started section. All right. Emma's birthday, you're going to analyze the graph. The first question it's asking you is, can you please explain the graph and determine about the situation from the graph? Then we're going to, what do the plotted points mean in terms of the situation? Do all the values on the line make sense in terms of the situation? And can you determine an equation for the graph? Let's take a look here. All right. Okay. So explain what you can determine about the situation from the graph. So let's start by reading the axes. So the x-axis is the days since Emma's birthday. Remember, that's going to be your independent variable. And then the number of cards received. Okay, number of cards received since her birthday. All right. So for every day from her birthday in the future, because today 0 would be her birthday. So after her birthday, right? That's days since, and then this would be days before. Right? So if 0 is the birthday, days after, days before. And then number of cards received, looks like we're going all the way up here, staying in that kind of positive range with our 2 points. Okay. And as her birthday approaches, she's getting more and more cards. As it gets closer, she's getting less and less cards. So this is the number of cards she received. Sorry about that. Noise got a little noisy up there, so I paused it. Number of cards she received for her birthday. It also says the days since her birthday. And then the number of cards received on any given day. So it's got a little bit there for us. First thing is kind of that y-axis is the numbers she received. There's the number of cards, right? The days since her birthday, so after and before, right? And then the number of cards received on any given day. That's really what's going to be on that line there. So what do the plotted points mean in this situation? So let's start with our first point right here where we have 0, 5. 0 in the x-axis. I'm sorry, 0 on the y-axis. So no cards received. And then it's 5 on days since birthday, positive 5. So no cards received 5 days after birthday. Okay. We're going to do this whole section together. All right. So don't worry about having to do any of these problems on your own. All right. The next point was, I'm sorry, I wrote that one backwards. That is Mr. Barnett's fault, going too fast. All right. So the first point is 5, 0. So right here, no cards received 5 days after birthday because she's got 0 cards received, 0 on the y-axis, and she's 5 days positive past the birthday. Now we're going to go to 0, 5, 0 on the x-axis because it's right on the y-axis, and then we're going up 1, 2, 3, 4, 5. So this means she received 5 cards on her birthday. And I know this because 0 days since or from her birthday would be on her birthday, and she had 5 cards come. And then back here, way back here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 right there. So minus 5 on the x-axis, right? And 10 on the y-axis tells me 5 days before her birthday, she received 10 cards. Because again, y is the number of cards she received. This is her birthday, and this is days from her birthday. So minus 5 would be 5 days before. Positive 5 would be 5 days after. Minus 5, 5 days before her birthday, she received 10 cards. Okay. So do all the values on this line make sense in terms of the situation? Okay, I'm going to say yes, they do. All right. I'm sorry. I'm going to say no, they don't. Mr. Barnett kind of fell into a trap here. It says, do all the values on the line make sense? I thought that I read it as points. And all the values on the line make sense. No, they don't. Because you can't send a half a card. You can't send a quarter of a card. They don't make sense. Because the data is discrete. You can't send a partial card, right? So this should really be on integers, right? And you only get mail once a day. So really, it should be discrete data with points instead of a line. get mail once a day. You can't send a half a card. Each day has to be a point. Each card has to be a point. So really, these values in between the integers do not make sense. I can't send 5 and a third cards in the mail. Okay. All right. Okay, now it's saying, can we figure out an equation for this graph? So let's take a look at the points that we do know, right? We have -5 and 10. Okay. We have 0 and 5. And then we have 5 and 0. Okay. So let's start with this one right here. This one's really important for us because it really tells us when x equals 0. So when x equals 0, we're going to start this as y equals. When x equals 0, what does y equal? Well, it equals 5. So x plus 5 must be part of the answer, right? Because if I put 0 in for x, y equals 5 on my line, okay? So y has to equal that, all right? Now, does that work for every point? Y equals x plus 5. Well, if I have y, if when x equals 5, y does not equal 10, it equals 0. And when x equals -5, y doesn't equal 0, it's 10. So it must be the opposite of x. So we're going to say if I put in y equals the opposite of -5 plus 5, that would be a +5, and now y equals 10. So that works for that one. And if I put in a 5, y equals the opposite of 5, which would be -5 plus 5 equals 0, it works for that point as well. So y has to equal the opposite of x plus 5. There will be easier ways to find those equations, but that's a good way just to start using those points and the data to go forward. Hope this helps.